Hi, this is Professor Fernandez, and this is Lesson 3, Video 1. We are talking here about factoring polynomials. So I have 3 examples here to go over, and each one of these is going to illustrate a different factoring technique and also go over some tips and tricks for factoring. One thing I want to point out is that all of them make use of the rules of exponents. So this is a concept that we talked about in Video 1.4 in the series. So if you want to go ahead and review that, you can head over to that video. Okay, so let me zoom in and talk about this first example here. So one of the things I like to do when I'm trying to factor is to try to find common factors, right, of course, in each of these terms, but also to think a little bit about the structure of what I'm looking at. What do I mean by that? So if you compare these first 2 examples, notice that they have 3 terms, right? 1, 2, 3, 1, 2, 3. This last example is different. So this one has 4 terms, okay? It is often the case that a factoring by grouping strategy is most effective when you have 4 terms, and we'll see that in part C. So if you don't have 4 terms, it doesn't mean you should try something else other than factoring by grouping, but if you don't have 4 terms, it means that you might want to start off with one of the other factoring techniques first. So the next thing I want to do with factoring is I want to look at the actual terms and see if there's anything in common. So I notice here, and we'll do that by looking at the numbers first, I notice here there's a 6, a 3, and a 9. The greatest common factor of those is 3. So I already know that I'm going to factor out a 3. And then I want to look at the terms that involve powers of x. So I have x to the 7th, to the 4th, and to the 3rd. Greatest common factor there is x cubed. So what I want to do then is I want to factor out a 3x cubed. I'm going to do that by dividing this by 3x cubed. And this is where you can see over here that we're going to need to use rules of exponents, right? So again, going back to this video to remind yourself of how that works. So let me do the first division here. So if I divide these 2 terms together, what do I get? Well, the 6 divided by the 3, that gives me 2. And then x to the 7th divided by x cubed, I'm dividing, so I subtract the exponents. That's x to the 7 minus 3, x to the 4th. So I get 2x to the 4th. Great. And then what if I now focus on the next term? So I'm dividing 3x to the 4th by 3x cubed. The 3's cancel. The x to the 4th divided by x cubed just gives me an x. So there we go. And then the last term, what if I divide negative 9x cubed by 3x cubed? Well, the x cubes go away. Negative 9 divided by 3 is negative 3. Okay. So I've now, if I erase everything and we look at this plainly, we have this nice statement that the original polynomial I started off with, when I divide it by 3x cubed, equals that. So now I can just multiply both sides by 3x cubed. And this is the nice thing about doing this on the tablet. I can move this thing over. Of course, it takes away half of the equal signs. And then I can just put this 3x cubed over here and then multiply it because we're multiplying both sides. So that is my factoring of this polynomial. Great. So now we've illustrated a few of the strategies of how you might think about starting a factoring problem. Excuse me. So let's apply that now in part B. So same thing. I'm going to look around, look at the numbers, see if they have any common factors, look at the variables, same thing. The leading coefficient here is 1, so I'm not really going to factor any number out like I did the 3 in the previous example. So I'm going to go straight and look at the variables. If I look through here, I have a to the 3rd, a to the 10th, a to the 5th. So the smallest of those is a cubed, so I'm going to factor that out. And then now let's look at the b's. So b to the 8th, to the 4th, and squared. Smallest of those is squared, b squared. Great. So I'm going to do the same exact process I did before. I'm going to divide this by a cubed b squared. And let's see what happens. So we'll do term by term as before. Great. Look at the first term here. If I focus just on the a's, a cubed, that leaves me with an a. That leaves me with a cancellation, so I don't put any a's. If I look at the next term, b to the 8th over b squared, that gives me b to the 4th. So I'm going to put a b to the 4th here. Then I'm going to put a parenthesis here for later when we multiply things out. Okay, great. So I have a b to the, b to the 6, right? 8 minus 2 is 6. So b to the 6. Okay, and then I move on to the next term here, which is this middle one. So this one has a minus 7, right? So I keep the minus 7. And then I have a to the 10th over a cubed. That gives me a to the 7th. Great. And I have b to the 4th over b squared. That gives me b squared. And then next one, last one here, which is the 2a to the 5th, this term divided by a cubed b squared. So I keep the 2, so plus 2, and then a to the 5th over a cubed, 5 minus 3, so that's 2 to a squared. And then b squared over b squared, those cancel, so that goes away. So I just have a 1, a multiplication by 1, b to the 0. So that is the end of my division. And then as we did before, now we just take this denominator and we multiply it over here, right? And that is our factoring. So factorization. So we can write this polynomial in this nice factored form. As with all these examples, right, you can, even for the two that we did here, you can continue to ask questions like, does this factor even further? Or maybe, does this factor even further? Okay. The reason I'm not going further with these is that because I see no other factorization here. Sometimes there may be a factorization. It may be very complicated to get there. But in a typical class, especially my class, I would expect you to show one way to factor. In other words, at least factor it out to here. If there's other ways to factor, if factoring is the point of the problem, if you can factor further, then I would want you to continue if it's reasonable. Right? So not if it involves some sort of irrational fractions and complicated, subsequent factorings. Great. So I'm going to move on here to the third example. This is the one that I mentioned at the beginning, remember, that has 4 terms. So this is probably a good candidate for factoring by grouping. So notice that, if you didn't try that route, I could definitely factor out an x because every term has an x. Not every term has a 7, but every term has an x. So if I tried that, I would end up with this. I'm just factoring out the x out of every term. Okay, and then I would look at this and I would say, I don't see any more common terms, right? That's kind of as far as I can go. So this is certainly a factorization of this polynomial, but it is not the nicest or best factorization. And then again, I'm left with this nagging thought of there are 4 terms here. There might be a factoring by grouping that I can do. And actually, I can continue the problem from here, but I'm not going to do that. I'm going to go back to the original problem because actually there's a little bit of symmetry hidden in this original problem that hints at the next step that we can do that is different from what I just erased. So let's take a look at this part. These first 2 terms have a 7, and they have at least an x, right? So I can factor out a 7x, and that would leave me with just a 1 here. And out of here, I would get a plus x squared. Great, so that is my first step, and it tells me that I'm probably heading in the right direction because that factored out really well for those first 2 terms. And now look at these 2 terms. So they don't have a 7, but they have a 1 in front of the powers of x, and also they have a x to the 4th in them. So plus, factor out an x to the 4th. I get a 1 from this term, plus, and then over here I get an x squared. Great, and now notice what has happened. Each one of these 2 terms, this one and this one, has a 1 plus x squared in it. So I can factor that out. Okay, so if I factor out a 1 plus x squared, from this term here, what is left over? Well, what's left over is just this 7x. So 7x. Okay, and then plus. So now I go back and I look at this term over here. I factor out a 1 plus x squared. What is left over? Just this term, x to the 4th. X to the 4th. Great, and now this is an example of what I was talking about earlier. Notice that, this is certainly a nicer factored form of the original polynomial, but there's also more that we can do. Because if we look inside this bracket here, we have an x here, we have an x to the 4th there, so I can factor out an x out of those 2 terms. And what am I left with? Well, the 7x becomes a 7 when you take out the x, plus, and then the x to the 4th becomes an x cubed when you take out the x. Great, and then this is my final factored form that we can consider as a very good answer. Great, so now we've done all 3 of these examples, and then just to wrap up with a little review, if you're going to factor a polynomial that has 3 terms in it, you might want to go ahead and use some of the usual factoring techniques. i.e. not factoring by grouping. If you have a polynomial that has 4 terms in it, probably good to think about using factoring by grouping. Maybe not initially, or maybe so, right? But just have it somewhere in your mind as something you might want to try. Okay, great. I'll see you in the next video.